Marcell was a speaker at Meeting C++ this year with his talk about hacking and securing C++. So that's basically what we'll talk tonight about. But Marcell, let's start with an introduction. What do you do with C++?
Yes, welcome everyone, and thanks for having me. Yeah, I mainly do embedded systems with C++. Of course, that involves a lot of things. Some embedded Linux systems, some bare metal programming, a lot of low-level stuff. Also involves a lot of legacy C code management, as one can imagine. But yeah, I'm mainly moving around in the embedded field with C++. Yes, just another short introduction. Professionally, I'm working at Zurich, Austria, there as an embedded software developer. And luckily, there we are also enforcing as modern C++ as the client allows us to do. So we are luckily very, very modern on that part.
Yes, so let's quickly go back to your talk. What are the exciting things you can tell us about your talk about hacking and securing C++?
Yeah, so it will be, I think, more on the hacking side. Of course, there will be also some aspects regarding how to secure the C++ code. But when I started to work on this, it wasn't yet a presentation idea. I started to look into cybersecurity. And also on that part, I looked into hacking and all of this modern high-end hacking. It's just automated scripts. When you look at the version of a software, you generate some payload and you send it to the remote machine, and magic happens and you get remote access. And what I was really interested about is what actually is this payload that we are sending? How does this affect the hardware? What happens there? How do we get from a simple memory bug like a buffer overflow? How do we get from there to a remote shell? Because that for me, this was a huge step that I didn't understand. And as an embedded developer, I was very interested in this lower level aspect of this hacking thing. So I started to look into it. I prepared an embedded device. The talk will not be specific to embedded devices. I have to be clear on that. But the reason for me preparing an embedded device for this is the simplicity of it. So embedded microcontrollers have a much simpler memory architecture. You have a much more direct access to the memory. There is no virtualization. There is no randomized address spaces. So all of these things I can just avoid and look at the actual hardware. I can look at fixed memory addresses. It's much simpler to work with an embedded device. So I started to work on this topic. I started to experiment with it. I specifically specifically created bad code. So this will also be an interesting aspect about this talk, that most of the code that I will show will be code to avoid, code to how not to do things. So I started to write this code, started to understand how these payloads work, how I can prepare my own payload, how I can send it to the device, and what happens at the level of memory. And this will be the thing that we will go over in my presentation. We will look at different areas such as the stack, the heap, and lastly the buffer, because buffer overflow is one of the more interesting things that one can exploit. And we will see how this magic happens, how you can send some binary code to a device with buffer overflow bug, and how you can basically do anything with that device. And also we will see some countermeasures that we as developers or Also, if we are in a system developer position, what we can do, what protection mechanisms we can use, what we should avoid, and how we should use modern C++ to avoid these things. And also, it's just my personal viewpoint on that. It's in the recent years, there is a lot of talk about memory safety and security of C++, other programming languages. I am more on the side that from what I see, most of our memory-related bugs originate from the C origins of the language. And if we were to use C++ to its full extent, modern C++, then most of these memory-related bugs wouldn't be an issue.
Yeah, I, on this behalf, quickly want to share this tweet from CPCon, which is now a few years old, where Herbsetter said that, more than 10 years ago, that memory safety would be a solved problem in C++ soon. And, that's still not the case. And I guess when you want to be that close to the hardware, it's really hard to, I guess maybe he had transactional memory in mind or something like that, which unfortunately didn't really come through, I think. But generally, I think maybe we should move on to this C++ and safety. What is your experience in this direction then?
Yeah, so my experience in my line of work as embedded developers, it's rarely the case that we are building something really from scratch with modern C++. Most of the time we get already existing projects that were written in the 80s, whatever, older than me, running really legacy C code, and then we add layers of C++ onto it. And my experience is that most of the memory related issues are either coming from the legacy C code, or they are coming from C++ developers or C++ code that is, although C++, it is not, it is C programming wrapped in C++ wrapper, where you have you implement a huge class, and yes, it's a class, you can have objects, but everything is then just put into this one class. You are calling C functions, you don't really work in the object-oriented way, you don't really use the C++ features that I think are safe and are making the language safe. So as long as we are using row pointers everywhere, C-style arrays, and stuff like that, sure, there will be problems with that, but that's not C++. C++ is using unique pointers or smart pointers. It is using the provided containers from the standard library. It allows us a way to, for example, to couple the row arrays with their sizes, and when you do that, it is much harder to mess things up. It's still possible, but it is much harder. And if my philosophy is that if we were to use proper C++, even if not properly all the time, most of these bugs would disappear. You still have the ability to make it happen, but it's much harder.
Yeah, I think there's always this difference between theory and practice. And especially in the embedded field, you often also have a lot of code coming from vendors.
Yes, exactly.
Is kind of a black hole or a black box for you. And you said you're coming from the embedded space, so I thought it makes sense to quickly go into Misra. And are you working with Misra?
Well, I worked with Misra. I must admit that I know that there is a newer Misra standard. I think it was a Misra 23. That's the newer version for C++. I haven't worked with that one yet. I will only worked with the previous versions. I don't like it, to be honest. For me, it's also not the C++ way to do things. Specifically, what I really don't like about the Misra is this one return policy, that you have one return statement in the end of the function, and you have like huge indentations with a number of nested if and else and for and whatever. It just goes on, and then you're just kicking around the return value throughout the whole function. That kind of kills the C++ way, because you cannot really use this resource allocation principle where you have scoped guards around objects, and then this if you set your base code base up well, when it's time to use it, then you cannot make these mistakes. And if you return from the middle of the function, then you are fine, because everything will be handled automatically. That's the beauty of it. And this one return statement policy just makes things really unreadable. I've heard that this one was removed from the 23 version. I hope it was. I'm not sure, because I haven't looked at it.
It's actually a comment we're getting from LinkedIn that one return is not a requirement for the 23 version of Mistra.
Mm-hmm.
So
yeah, I hope that's the case.
But still, if you have a code base which has to adhere to Mistra, because of let's say contractual requirements, then you have people being used to the style of code, and having that removed helps, but it doesn't change your code base, right?
Yeah, that's true. We have it all around. Today I was also working on some legacy code that we have around for like forever. It is also written with this one return policy, and it's much harder to read it. And of course, it's full with go-to statements, so that's just another layer.
Okay, so goto is allowed in Mistra, or you're using
I'm not sure if that code was written according to the Misra standards. I know that it was written according to this one return policy. I'm not sure about the go-to in the Misra. I hope it's not allowed, but I'm not sure about that.
Okay. So regarding safety and security, which tools do you use?
Well, we implement a lot of different tools. We have static analyzers that go over our code and pick out a bunch of different error messages. Right now, what I use, I'm currently going through some legacy code and hunting for memory leaks specifically. And there I use Volgrind, address sanitizer, whatever tool I can. Most of these are, of course, the free open source tools. And so the things that we can use on a Linux-based system pretty easily. On the other hand, the best tool is modern C++. And the moderner you can go, the better. And if you go for the most modern C++ version and use it to its full extent, then you won't have much issues.
Yeah, I think that applying modern C++ is sometimes the answer.
Yeah, I think so.
So it doesn't replace things like fuzzing, because if you write parsers, it's just hard. And
yes. So regarding tools, I couldn't name one specific tool that we use. It's really whatever gets the job done. It's different from client to client. So Stuka Austria, where I work, we are a service provider company. So the beauty of it is that we can work on different projects for shorter periods of times, and every client has their own tool sets that are required. We mostly use what they prefer all the time.
Yeah, I remember that from my days as a freelancer. So what have you learned about C++ from working on your talk?
Well, a lot of things, really. I have learned, so for me, when I started to learn C++, I can remember back at university, and for several years, for me, dynamic memory allocation was always like this magic thing that just happens. You ask for some memory from the operating system, and the operating system provides this memory. This was the way that we were taught about this in school, and you didn't really think about this kind of stuff. You just call new and it works, and we or malloc, and we don't often even check the return value. And the same about stack. I know that my local variables live on the stack. That's something that you as a C++ developer just know as a fact. But it's really about, for me at least, how that looks like. So what is the representation of your variables at the level of memory or at the level of assembly code is really interesting for me. So I learned a lot about how the stack works, how the heap works, and how dynamic memory allocations work. I learned a lot also about buffers, how they work, how they look like in memory. So it's more like I learned a lot about the connection between C++ and the hardware. So when I look at the C++ code now, I better understand how that would look like when it is compiled to binary, how the binary would look like, how it would execute. I just have a clearer view on this part of C++. From this talk, when preparing this talk, I didn't learn much about modern, newer C++ because my goal was to write bad code so that I can exploit the device, I can attack it. And if I were to use modern C++, then it would be harder to write bad code.
But I assume you have examples how to, you have good code to your bad code, right? In your talk.
Yes, sure. But they are straightforward. So for example, if you have a raw C-style array, that's pretty easy to overrun because you are always iterating over it with some size constant. If you mix up the constant or you don't check your boundaries, then you are over it and you have a buffer overflow. If you use a standard array or if you use a standard vector, then you have the size there, and you can use range-based for loops, and it becomes really hard to over-index a buffer when you have the size coupled within the data structure, and you have to put in extra effort, and these things are pretty trivial that we use every day, and it's not like that I just now learned that vector has a size to it. But yeah, sure. I learned a lot regarding the connection between C++ and the hardware.
That's always good to know about. So people coming to your talk, what will they learn?
Well, I hope what they will learn is how these bugs work. So we know that these bugs exist. We all know these terms: buffer overflow, use after free, dangling pointers. We are all familiar what these are on a conceptual level, at least. And my hope is that people will walk away from this talk knowing what makes these vulnerable bugs so bad that they actually become vulnerabilities, and what is it about them that is so bad that hackers can actually attack a machine like with this kind of bug, and how they can use this bug to get remote access or execute code remotely on another device. And my hope is that if people see this, if they understand what are the stakes, how really small looking bugs can have huge impacts, then it will sit in the back of their minds, and when they are writing code or looking at code, and they will think to themselves, okay, yeah, I have seen this, I know how this works, I have to be cautious about this, that, or that, and then we will have less and less memory related bugs. That's my hope.
I agree with that. Did you have any vulnerabilities which you saw like live, like in related projects you've been working on?
I mean, vulnerabilities that could have been exploited, I'm not sure about that, because there a lot of things have to line up for a vulnerability to be exploitable. Of course, I have seen a lot of dangling pointers. I have also seen buffer overflows, but to know if a buffer overflow is exploitable in a way that would be beneficial, there you have to put in a lot of extra work. So it's not a surprise that nowadays there are 0-day vulnerabilities that come out, and even for old software, it's not clear that there is this vulnerability. Even if you see a bug, it's not clear how you can exploit it. But people are finding their ways, and yeah, sure. I probably have seen bugs that could have been exploited. The easiest exploit is always just make it crash. And if you have a null pointer reference that you can call somehow, that's probably the easiest one. Then the software will crash and you can cause a denial of service attack of some sort. And that's without going very deep into buffer overflows and payloads and stuff.
What's your opinion on like upcoming C++ security features like contracts or I mean, like especially like with contracts? Have you looked into contracts?
I have seen talks about contracts. I'm not too familiar with them. From what I've seen in this talk, they look promising, that you can check precondition, post conditions. So it sounds interesting. I haven't really looked into that. For me, it's like far in the future and I get to use these. But from what, so my favorite newer C++ features that one can use to mitigate some of these bugs is, for example, concepts and templates. If you have the privilege to do something at compile time, you can do a lot of checks and really validate everything. Concepts are a great tool for that. So I think that's pretty much maxed out to an extent, and I hope that with contracts you will have a runtime thing to do that as well. But it only works when people use it. So
That's true. I think we do have a contract talk, and we had the contracts talk last year, so I think it will probably also be a popular topic to speak about. I'm very much looking forward to see practical examples of actually contracts working in code bases.
Yeah.
It's still very much abstract, and then of course there's always the other safe languages like Rust. Do you have like an opinion on these languages, which by default?
I mean, sure. Rust specifically, I tried it. I've written code in Rust. I also have some projects running in Rust. I have seen that it is becoming more and more popular. I can see why. So at Zuke, we also have projects that are running in Rust, and they have been running for a couple of years now, and they are reporting. Just a month ago, they had a presentation that they had no memory-related issues with Rust. That's great. I mean, that's a good thing, I think. But for me, I don't like I don't like it. It's more like if when I'm used to C++ already, I know C++. To me, it looks like it looks different. For example, Rust uses move semantics as a default when move semantics is pretty hard to understand. I think that's a bit confusing and unnecessary, but there is probably a reason for that. So just the programming style of Rust is not really for me. Yeah, that it is memory safe, I can fully support that. That's great. But for me, there are things that are missing. And always when I look at the Rust code, all I can see is, yeah, sure, you can do this in C++. You can do that in C++. You can do everything in C++ that Rust can do. Yeah, it is not enforced by the compiler, but therefore you have more freedom in your hand when working with C++. You then don't have these constraints like Rust does. So I think for me, at least, it's a choice of language, personal choice. I personally don't really like it, but it's great that others find it interesting
Yeah.
and good to work with.
Last week so this year I started posting C++ jobs as a newsletter. So I have now kind of almost 6 months of experience with looking for C++ jobs on LinkedIn. And due to a comment on social media, I was then getting curious, like what's with other languages? If I look for Rust, how many jobs do I find? And in Germany, I currently find like a couple of thousand C++ jobs, and for Rust, it's a couple of hundred. And in the US, it's similar. And the original question was about Zig, which is even more exotic. And there's like no Zig jobs on LinkedIn in Germany. Maybe I need some other search term or something to find them, but actually Zig as a search term worked in the US and found 2 jobs. So I think like the vast majority of the industry is on C and C++.
Yes,
And
I think that it's still C that makes the word turn around, as the old saying goes. And C++ is a great addition to that, a great extension, and a great alternative. But even C++ couldn't even come close to replacing C. C legacy code bases are all around. I'm not saying that Rust would anytime soon replace C++ or even try to do that with C. But what I really like about Rust is that it pushed C++ a little bit closer to memory safety. So that we have these talks in recent years about the safety guarantees that C++ could provide, getting rid of undefined behavior. I think that in the long run, this will be very beneficial to the language and to the community and the users. Also, the software that we will have less or fewer bugs. But I think that at the end of the day, it's my personal experience. Most bugs are coming from the really old legacy C code bases that won't go away anytime soon. So yes, that would be my opinion on languages like Rust.
I think it's my opinion is similar. The industry is there. I mean, the C and C++ code base is so large, and
Yes.
nobody will like rewrite this in Rust. That's
No.
completely out of the question. So that's
No.
why interoperability with Rust is such a big topic, where I see so many people trying to talk about that, or like this is the foot in the door for many of them, I guess. And generally, yeah, with C++ and safety, we actually have this as a big topic this time. Anthony Williams has decided to keynote on that, on software and security or something like in this direction I remembered correctly. And also James McNellis already gave last year a lightning talk where he will give an extended version, not an extended lightning talk, but actually share his experiences with securing code and C++ that is the source of that code in their environment, Roblox, which is really interesting. I think that embedded often has the experience and the advantage that it's not so much connected to the web.
Yes. Well, nowadays with IoT, but even so, yeah. Yes, and but one last thought about that, about rewriting. You mentioned rewriting code, and when that could happen. I have worked on several projects in the last years. It took, and I have seen different workflows, and one that is a bit extreme, I would have to say. But there was this project where we had really old legacy C code, and if you find a bug or something like that, then you make a ticket for the owners to change it, and even that can take years. Sometimes it's rejected, even if it's accepted, at least months, but it could take years to get something changed in those code bases. That there are really a lot of equipment, a lot of devices that are running that code. It's not trivial to change it. It's far less trivial to rewrite the whole thing. So that won't go anywhere.
Yeah, it's definitely an interesting ecosystem we are living in.
Yeah.
And so if the audience has any more questions, they're welcome to ask it now. I think there's now like half an hour. I'm pretty much through with my questions, and I'm looking forward actually to your talk and to the other all takes on safety and security. We see this here on the conference. I think it's very much an important topic to talk about.
Yeah, I'm looking forward to it as well, and other talks as well. Yeah, it will definitely be interesting. And for anyone who is interested in the hacking side of security, if someone is interested in not just building things, but also breaking them, then just come to my talk and you will learn how to break things.
That sounds good. All right. I don't see any more questions from the chat, I think. There's a couple of comments, but nothing really on the topic. So thank you for your time, Marcell. And
yes, thank you as well. Thanks for having me.
see you in Berlin.
Yes, see you in Berlin. Looking forward to it.